starting with the mathematical method. Before we talk about the complex one, the advanced one, we just need to talk about a few special cases, which is when they are in same direction. Same direction, you simply add. So we had an old vector, 5 Newton, for example. You want to add it with a new vector, 7 Newton, for example. Everything just comes out something much longer, but 12 Newton. Next is if they are in opposite direction. If they're in opposite direction, we still don't have any mathematics there, you subtract. What if they are at right angle to each other, both acting at 90 degrees now? For that third method, simply use Pythagoras rule to get the resultant. And at the end of the day, you get your arrow with the square root of everything there. Why, if you want to get direction, you just do tan theta, the same way we did it last time, will be 7/5. So there is no problem. These are the 3 special cases: same direction, opposite direction, and then perpendicular to each other. So the man travels 8 kilometers due west and then 6 kilometers due north. How does that work? So this is an easy case, sorry. This is still an easy case. So 8 kilometers to the west from this starting, and then 6 kilometers due north. So this one is the easy case. Our arrow will simply be square root of 8 square plus 6 square, because it's forming a right angle triangle. Okay, this is an easy one. Our arrow is just 10 kilometers. All right, 10 kilometers. And if we want to depict the direction, we need to figure out this angle. So the angle becomes tan inverse of the 6 divided by 8. So let's see what happens when there is just any other random angle between them. See, if you have a certain vector given to you and another vector given to you, this is the university stage. There are many things they're not going to do for you. Your first job will be to try and connect head to tail, meaning that you will have this and then this. So we already know that this resultant here will represent the addition of the vectors. For us to be able to solve it mathematically, you need to know the value of A, know the value of B, and work out the angle that lies between two of them when you have connected it head to tail. Very crucial. When you have connected it head to tail, you need the angle between them to get resultant. So resultant will be using cosine formula, which says our root square will be the first one square plus the second one square minus 2 times the first and the second, cos that angle between them. This is quite different from how it was done in the secondary and high school pattern, because in the high school pattern we are usually given the angle that lies between two of them, so it was using a different approach. But for the university, we are going to be giving you these vectors using the advanced vector notation. So it is up to you to to mentally produce what the first vector will look like, both in terms of the value given to you and the direction given to you, and then you also draw what the second vector looks like, both in terms of the magnitude they provided and the angle they provided for you. So when you sketch these two, it's up to you to be able to create them in one graph. Don't worry, we're going to do it, and then figure out the angle that lies between them. That is the only time you can use this formula and get the right answer. So let's go straight into an example and see how this works. We're given two vectors using vector notation, like I said. The first vector has a magnitude of 120 in the direction of 30 degrees to the horizontal. Second one has a magnitude of 70 in the direction of 150 to the horizontal. In order to get the resultant for this type, I'll start with the cheap method. I call it cheap. You can employ it. It works. It works any day, anytime. So let's see this. What we'll do is we'll break down the P into X direction and break down the P into Y direction. So what does that mean? We know that according to what I taught us, is going to be P cos theta. So 120 cos 30. This is going to be P sin theta. 120 sin 30. So what does this give us? 103.9, and this gives us 60. These are the values. We also repeat the same for Q. We resolve Q into X and Y as well. Q in the X direction and Q in the Y direction. This is going to be 70 cos angle is 150. gives us negative 60.6, and then Q in the y direction is 70 and 150, and this gives us 35. Now that we have it, our resultant we have x-axis, and our resultant we have y-axis. So on the x-axis of our resultant, we'll add algebraically the values that was produced from the horizontal component of both. So we have 103.9 minus 60.6, so this becomes 43.3. we repeat the same for this. This gives us 95. So what does this mean? It means that our resultant is moving in a positive x direction because it was a positive answer at the end. That's 43.3, and it's also moving in the positive y direction, which came out as 95. So the diagonal I will draw represents the true value of the magnitude of the resultant. So that means that the arrow itself becomes square root of 43.3 square plus 95 square, 104.4. Now that's for the magnitude. In order for us to get the direction, we use tan theta. So for direction now, theta will become tan inverse of 95 over 43.3, and this gives us 65.5 degrees. So the value of the resultant is simply 104.4 at an angle of 65.5 degrees. So that's the first method. Very easy. I'm sure we all like it. We will most likely use this. Nobody will give you which rule to employ in the exam, but most important thing will be your final answer. Now let's use the second method of sketching it and then using cosine rule to solve. You've seen the first method and how easy it was to arrive at the resultant. Now let's see a unique question using the second method that we employ the use of cosine formula. Remember I said you must be able to mentally sketch what we are dealing with, connect it head to tail, figure out the angle between them before we can solve. So if this is my horizontal line, 30 degrees is still within the first quadrant. So this is 30 degrees and this is the force of 120 Newton. Now, where you ended, draw a new horizontal line so you may begin whatever the sketch was for the second. So the second person is 70 on 150. So now if this is a cardinal point, 90 stops here, 150 is into this second graph. So we move this way to locate the second one, which is 70 Newton or whatever it was. And the angle is 150 here. So what that means is that what's left on the horizontal is 30. 180 minus 70. So this is 30. If you transfer alternate angles from here, alternate angles are equal, which means this part was also 30, just coincidentally, right? So what does that give us? It means that the total angle between two of them is 60. This is still the 120 here. So you can draw here to anywhere you want, but connecting the beginning to the end becomes our resultant. And we can easily get the resultant value using the cosine rule. While we will get the direction, we already know all the way to this place, so we need to still later find this angle here, so we can add it to 30 to get the true direction. So now that we have a complete triangle, remember the rule now, I said it to be arrow square will be the first one square plus the second one square minus 2 times the multiple of both of them, the product of both of them, 120 times 70, cos the angle that laid between them when we have drawn them head to tail. So that's 60 degrees. What does this give us? 14400 plus 4900 minus the product of all three gives 16,800 cos 60. When this is carefully resolved, everything becomes 19300 minus 8400 for arrow square. So arrow becomes the square root of this, which is 10,900. So our resultant is 104.4. So you can see that the resultant has also given us exactly the value we got last time. Now let's work the direction. To work the direction, this is what we currently have. We have here as 60. We have found the resultant as 104.4, we have here as 120, and we have here as 70. So in order for me to get this theta here, I'll use sine rule. Sine rule would say 104.4 divided by the sine of his angle will be the same as 70 divided by the sine of what I'm looking for. If we cross multiply, and only sine theta becomes 70 sine 60 divided by this 104.4. At the end of the day, when you take sine inverse of everything, our angle comes out as 35.5. But remember that I said what you found should be added to the original, because direction is talking all the way from horizontal. So therefore, your direction is now going to be the 35.5 you've gotten plus the 30 that was there. So everything is 65.5. 65.5. Therefore, how do you represent your resultant? Now we'll say it is simply 104.4 in the direction of 65.5 degrees. That is how easy it is. Now, the triangle will not always look this way. It all depends on the angle of orientation given to us, but it is always going to utilize this method. If I had an angle that is greater than 180, it will burst into this side, okay, and thereby reduce my sketch, but it doesn't change anything. Once you're always sketching head to tail, we'll always have the solution to what you want. Now, if there are any unique question you would like me to work on, you can send it directly through the chat section, the comment section, or you inbox our Telegram channel so that we can handle it together. I will still have just a few more questions, but then that will come in another video. For now, this is it. Have a great day.